Hello everyone. I wanted to work a problem from the last section in the chapter on functions. It is called Business and Economic Applications, and it's a wonderful moment in the course because it really is some marvelous mathematics, and you could get at it by looking backwards into graphs and lines, or you could get at it by looking forward into systems of equations. So it's a wonderfully balanced moment. I'm going to approach it differently though than the book does. I'm going to sort of hack this in terms of building everything on a piece of cultural capital that I think all of us have inherited from the world we swim in. Essentially here, let's look at this idea, the idea of profit. Let's imagine that we're running a business, and it's pretty basic, I think, to all of us that the profit of the business is going to be the money we take in minus the money we pay out. And so, again, I think we inherit this idea. It's part of our cultural capital. And if you want to be a good citizen and a newspaper reader, then you're going to want to take this idea to the next step, the business words, where profit is equal to revenue, total money coming into a business, and you subtract out the costs, the total amount that the business has to spend to conduct itself. Now, there are variable costs and there are fixed costs, and the book gets after those, but essentially we're talking about here the cost of machinery, the cost of labor, the cost of insurance, the cost of the building, etc. If you want to get deeper into it, you can certainly read the book for that. But I wanted to point out this the ubiquity of these ideas. Today is, in fact, June 18th, 2010, and here's a New Mexico Business Weekly web article that the revenue, one of the key words here, for Facebook in '09 is estimated to be near 800 million. And if I look in this article just a little bit deeper here, here's a quote here from an unnamed source that's saying there's solid net profit in the tens of millions of dollars last year. Solid net profit. So profit and revenue, these are essential terms to be a citizen, a functioning, thinking citizen. Now, the next step, though, is the hack. We transition into math speak, and here's what that looks like. Functional notation. It's presupposed here that there's a piece of mathematics that represents revenue, and there's a piece of mathematics that represents cost. If we were to subtract those, we would get to what's called the profit function, the total profit function. And that's what the first part of this problem I'm working asks for. It says that given these two functions here, this cost function and this revenue function, given these two functions, find the total profit function. And so essentially, I've rewritten the formula here. And notice what I've done here is I've put some brackets around the cost function, and I'm doing that because this is the moment where I see arithmetic errors creep in. And so approach it for now with this formula right here. That's what I'm going to do. Now, I've hit a lot at the idea of minus parentheses, and so I think all of us are old hands at handling that, but seeing it and handling it are two different things. So put in the brackets, if you will, please. Now, I've said also too a lot in the course that algebra is, it seems like the central move of algebra is substitution, and that's what we're doing here. Here's a mathematics that represents the revenue. It's a simple model. X represents something we're producing, and this will be the amount of money we'll bring in when we sell it. If X is 10, if we only make 10 of these things, it will make $580. If X is 1,000, we'll make $58,000. And the substitution comes in is that I'm going to replace the function notation with the bit of mathematics, the expression that it represents. So too with the cost function. That's going to go in right here. Now when I do that, we end up with something that looks like this. And of course, we've talked a lot about handling minus parentheses. And I suggested it's just multiplication by -1, and multiplication by -1 is a sign changer. So both of these are going to change in sign, and we will end up with this. And it's cleanup time. We have two like terms here, and that's simply done. Our profit total profit function, and I put a green box around it because this is the answer to part A, is 18x minus 8,010. Okay, I want to drag that up and talk about it for a moment. There's the answer to part A. Let's get rid of this. And what do we know about this? Well, we know we can replace p of x with y. And y is equal to mx plus b. That's the famous template that gives slope and intercept. And you can see that the slope here is 18. In other words, this thing is always increasing left to right. The growth will never cease. Profit is totally dependent upon x, and it will always grow. The bigger x is, the bigger your profit will be. And so that's not going to be the case as we move on in the course. There'll be situations where there's actually a sweet spot that there's a certain number of x that you should produce, beyond which you would actually start to lose money again. And if you made less than that, you would lose money. There's a sweet spot. And so you can see how this mathematics really gets at some intense business ideas. Now, the second idea is the break-even point. And I just want to talk about the profit function there. And again, you could reference this many different ways with a graph or with a systems of equations, but this is a fundamental idea about profit. We know that if it's less than zero, we're losing money, and that's a red ink, that's bad, that's a debt. Similarly, if profit is greater than zero, the phrase we use, and you'll actually see this in business pages, is keep it in the black. And that's good. Now, what happens if profit is flat? There is no profit. If revenue and costs are the same number, that is called the break-even point. And so, just realizing this, there's not much more to go to find part B. Here again is our profit function that we found in part A, and all I need to do is say I want this thing to be 0. And that will give me the break-even point. So let's clean this up and let's just simply solve this. Let me drag it up to the top, and here's what we're going to do. I'm going to get rid of this functional notation because it just makes things look more complicated than they are. Essentially, we're back in section 1.3 of our textbook. This is a equation with one unknown, and we just simply add 8,010 to both sides, and we would get this, and then we would divide both sides by 18, and we would discover that x was equal to 445. And we're done. We should box it, right? Well, hang on a second. This is the second moment when people fall down on these problems. Let me highlight this idea right here. They're asking us for the break-even point. And so the break-even point is an ordered pair. And we have found simply the x aspect of that ordered pair. We need to find the other part. And that will complete the solution to this problem. Now, how are we going to do that? Well, let's review something here. We know that the profit function is equal to the revenue function minus the cost function. A great piece of code to memorize, built on ideas from our cultural capital. Now we know the break-even point is when this is equal to 0. And for now, let's just forget this part right here and just talk about these two numbers. They're going to be 0 when they're the same. In other words, when the cost is equal to the revenue. And so, what this is telling us here is we can let x be 445 in either one of our two equations. And so, again, we are back into that idea of substitution being central to the course. I could put x into R, or I could put it into C, and maybe I should do both to check my work. At any rate, I am going to choose the easier route here. I'm going to let x take on 445 in the revenue function, since there's only one operation to do, multiplication by 58. Let's drag in the calculator, 445 times 58, and the answer is 25,810. And so here is the ordered pair that is the solution to part B. Now, what does that mean? Can we interpret that? Yes, the break-even point will come when we make 445 of the things that we're producing. Call it widgets. Um, and that will generate $25,810 in revenue and $25,800.10, $25,810 in costs. And they will balance each other, and that's the break-even point. Okay, like I said, very rich mathematics, and you can learn a lot. I just focused down on the idea of um, profit equaling what you bring in minus what you pay out. And from that idea, which is part of our cultural capital, I built the whole structure. And I think that those ideas are really good to put in your brain. Okay, I'll be talking to you soon.